All right, so let's go on to page 25. All right. So for page 25, we're getting to something called the conditional probability. So for conditional probability, we're given a condition, and instead of using the whole data set, you only want to use the data set that meet that condition. So in a drawing, this is a conditional probability. So instead of using the entire data set, you only use the data set that pretty much meet that condition. So in this case scenario, we're not looking at the entire sample space. We're only looking at the event A, because that's the condition that the data set had to be event A. So we're only looking at that. When we're doing an and statement, you always do it using the entire data set. So this is for an and statement. So for this one, you use part of the data. This one, you use the entire data. Any questions so far for conditional versus the and statement? Actually, let's scroll on down. All right. So I don't know if I went over the notation or not, but here, let me just go over the notation. So P, so we're gonna go over this right here. When you have P is signify probability. And then if you look right here, it says probability of A. And then if you look at the vertical line right here, this vertical line doesn't mean given that. Misspelled that. Given that B has already happened. So when we're using the conditional probability, the conditional probability just means that whatever's after the vertical line, that's the information we already know has occurred. So kind of think about it. If I tell you it's raining today, what's the probability somebody has an umbrella? Pretty much what would come after the vertical line is that it's raining, because I already know it's raining, and I want to find the probability that someone will bring their umbrella given we already know it's raining. So anything after that vertical line, that's the information that we already know. Anything before that is the probability that we want to find to see what's going to happen. All right, so in order to find this probability, we're just going to use this equation over here. So we're going to say the probability of A and B occurring, and we divide that by the probability of B. So the reason why you divide by the probability of B is because we only want to focus on data set that B has occurred on. So that's why you always divide by the given information. So whatever the given information, that's the probability you're going to divide by. All right. Any questions so far for the formula before we move on and do a problem? Cool. All right. So let me scroll on down. So let's go ahead and do this one. So for this one said the belief in one true love differ by education level. So it says people in a study were asked whether they agree or disagree with the statement that there is only one true love for each person. Is the level of a person education related to the answer given, and if so, how? A person education is categorized as HS, as high school degree or less, some with some college, or college, which is college graduate or higher. So the first thing, what I'm going to go ahead and do for this table, and I'm going to find the total for all of them. So we have to find how many total high school degree or less we have. We have to find how many some college or, well, some college we have, and how many people we have that have college level, well, college graduate or higher. So we'll do 3, 6, 3, added to 557 plus 20. So that will be 940. Then we'll say 176 plus 466 plus 26. So you get 668. Lastly, we'll do 196 plus 789 plus 32. And you go 1017. Cool. All right. So now we're also going to get the people who agree with the statement, don't agree with the statement, or don't know about the statement. So we're going to do 363 plus 176 plus 196. That'll be 735. Then we'll say 557 plus 466 plus 789. Then you get 1812. Lastly, you should do 20 plus 26 plus 32. You get 78. So the final thing I'm going to do, I want to get the total. So the total will be over here. So to get the total, we do 735 plus 1812 plus 78. And you get 2625. And that's the answer for A, 2625. All right. Any questions so far? I got any of those red numbers.
Yeah. Why are you adding, like, why is it like column and then like sideways? I don't know.
Well, you just want to add them in case for the problem they ask you for that information. So that way it'll be easier if you have to get it instead of having to add it individually. So just get the total for that way. If the question asks for that, you already have it, and you could use it really fast.
It's like the only thing is, okay, so did you add up just like one row, like the 946, 68 and one?
Yeah, so the 940, yes, this all added together.
Yeah, I know that. But I'm saying, how did you get the two? Oh, okay, so for the two 625, you just added like one of the total lines.
Yeah, so you could just add this, or you could add this. Both of them should give you the same answer.
Okay, okay, okay. I was just making sure because I was like, wait, did he add them all or? Okay, that makes sense. Okay.
Cool. All right, so let's do B. So for B, if you look at it, it says find the probability that a person agree with the statement given is already know that their education level is a high school degree or less. So for this one, what do we know? That they agree with the statement, or is it already given that they have a high school degree or less? So if you want, you can just put it on the chat, or if you want, you can just shout it out. So like what information do they already give us?
Um, high school degree or less.
Yeah, cool. So we already know they have a high school degree or less. So this is the given information. So if I'm writing this, we're gonna find the probability they agree with the statement, given that they have a high school degree or less. Okay, yeah, okay, if you look at the way I wrote it, it says given it is already know that their education level is a high school degree or less. So I'm already telling you their high school, well, their education level is that they have a high school degree or less. So for this one, just for fun, we're gonna do it using the formula. For that way you can kind of see that the formula will give you the right answer. All right. So I want to find the probability that they agree with the statement and they're a high school graduate. So pretty much the easy way to do this is to do this. So they agree with the statement and they have a high school degree or less. So to figure out the number that you want to use, you just want to see where do they intercept. So at what number do they intercept?
363.
Oh, 363. So you go 363, and you divide this by the total, which is 2625.
Wait, but um, wouldn't it just be 940 because we're just looking for the high school?
Well, for right now, we're using the formula. So if I'm using the formula, since it's the and statement you always divide by the total. In a little bit, you'll see how that will simplify it.
Oh, okay.
All right. So right
I
now, what I want to do, I want to find the probability somebody has a high school degree or less. So how many total people do we have that have a high school degree or less?
940.
Cool. Thanks, Anna. So 940, and you also divide that by 2625.
I'm so confused.
All right. Everybody good so far with these two fractions? Cool. All right. So then what you want to do, you just want to use basic math in order to be able to do this. So if you look at the fraction, I want to get rid of this fraction. So if I want to get rid of that fraction, you multiply by the reciprocal. So you multiply by 2625 all over 940. But you also want to do that to the top. So you do 2625. Oops. So you do
I'm just kind of confused. Like, why are we doing it like that? Like, in the sense of like, why is it 363 over 2,625 and then over 940 over 2,625?
So because both of these statements right here are, you always divide it by the total. Because if I want to get the probability of and statement, you divide it by the total. And if you remember, these are marginal distribution. This one you also divide it by the total. So you give it a minute, you kind of see what's going to happen. So if you look at the 940 and the 940, that cancel out. If you look at the 2625 and the 2625, that will cancel out. If you look at the top, the 2625 and the 2625 will also cancel out. So the only thing that you're left with is the 363 divided by the 940. And the reason why it's 940 because we said this was the given. Because if you remember on this one, we said given they have a high school diploma or less. So that way you're dividing by the 940 because we only want to focus on people who have a high school diploma or less. So that's how you do it using the formula. But you could kind of just logically do this because you could go like, hey, there's 940 people who have a high school diploma or less. And then you could go 363 of them agree with the statement. So that way you do 363 divided by 940. So that way, anytime you're using like a two-way table, you really don't want to use the formula. It will be much easier if you use pretty much just logic. But that's it for B. Oh, well, actually, let me get the percentage for that. All right. Any question for B? All right. So that will be equal to 0.386. So that's it for B. Let's do C. So for C, it says, what are the probability that a person agree with the statement given is already known that their education level is some college? So for this one, what's my given?
They agree.
Not that they agree. Because if you look right here, it says given is already known that their education level is some college. So for this one, it will be some college. We already know that the education level is some college, and we want to find the probability of those people who have some college. What percentage of them agree with the statement? Everybody good? Why the condition is that they have some college level? All right, so for this one, we're not going to use a formula. We're just going to look at the table and get the answer from the table. So how many total people do we have that have some college level? Cool. Thanks, Anthony. So yeah, so we have 668 that have some college level. So that means right now we're only going to focus on these. So of the 668 people, how many of them agree with the statement? Cool. Thanks, Anthony. Again, you're on a roll. So 176. So we're gonna do 176 divided by 668, and you get 0.2635 or 26.35%. All right, and that's it for C. Any question in regard to how we did C? All right, so let's do D. So for D, it says find the probability that a person agree with the statement given is already known that their education level is college graduate or higher. So for this one, we already know that they're college graduate or higher. So we're gonna find the probability they agree with the statement given they have a college degree or higher. So if you go back to the table, you're going to notice you have 1,017 college degree or higher. So you do 1,017 the bottom. And then of the 1,017, you have to see how many agree, which is the 196. So we do 196. So we'll do 196 divided by 1017, and you get 0.1927. Or if you want to put it as a percent, we could put it as 19.27%. Any question for D? All right, so let's do E. So for E, it says find the probability that a person agree with the statement and their education level is high school degree or less. So for this one, what seems to be the key word that tell us this is not a conditional? That this is a condition, that this is not a conditional probability. Cool. And perfect. Thanks, Lois. So it's the and portion. So since it's an and statement, that means you divide by the total. Cool. So for this one, we want to find the probability they agree with the statement and have a high school degree or less. So let's go ahead and let's find the total. So if you go ahead and look at the total, it is 2625. So that's what we're going to divide it by. 2625. And we want to find people who agree with the statement and are have a high school degree or less, which is the 363. All right, so I'm going to go ahead and work that out. So do 363 divided by 2625. And you get ourselves 13.8%. All right, and that's it for E. Any question in regard to E? So you do kind of want to know the difference between a conditional probability and an and statement, because if it's a conditional probability, you divide by the condition. If it's an and statement, you divide by the total amount of people who participated in that survey. All right, so lastly, we're going to do F. So for F, what we want to do, we want to comment on the probability for B, C, and D. So what does it look is happening as the education level is increasing? Do most people agree with that there's one true person for everybody? Or is it kind of going down?
It's going down.
Yeah,
Oh,
it's
wait.
going down. So it's kind of showing like the more education you get, the less and less you believe that there's one true person for everybody out there. Cool. And that's it for that last problem. Any question in regards to the last problem? All right, so let's move on down. All right, so that was how to use a conditional probability if you're given a table. So up next, we're gonna do a conditional probability when we're not given a table. All right, so for this one, so the probability that it is Friday and a student is absent is 0.03. Since there are 5 school days in a week, the probability that is Friday is 0.2 or 20%. What is the probability a student is absent given that today is Friday? So the first thing you want to do is go ahead and label everything. So the first thing we want to label is what is the 0.03 and the 0.2 represent?
Point 03 is absent and Friday.
Perfect.
And point 2 is just the day of the week.
So absent and Friday. And pretty much F is 0.2. Thank you, Amanda. Cool. So you get the probability that is a student is absent and is Friday is 0.03, and the probability is Friday is 0.20. All right, everybody good so far with that labeling? Wait. All right. So for the last sentence, what is the probability that a student is absent given that today is Friday? So this is the key word. Let's tell us this is a conditional probability. So anytime you see given that, that's your clue to tell you that that's a condition. And usually the condition come after the given that. So if you look at what come after the given that, it says today is Friday. So we want to find the probability a student is absent given that today is Friday.
How is that different than the 0.03?
Well, what's different from the 0.03 is telling you the probability they're absent and it's Friday is 0.03. But what's different for the last one, they're giving me the information that's already Friday. Because for the 0.03, they're not giving me the information that today is already Friday. They're telling me on a random day that the probability that a person is absent and is Friday is 0.03. But for the last one, the one we're trying to find the probability for, we already know it's Friday. So we don't have to worry about the day. We only have to worry about what the probability that person is absent on Friday. Because pretty much this is telling us we already know it's Friday. All right, so for this one, what we want to go ahead and do, you're going to get 0.03 and divide that by the probability that today, well, that's the probability that's Friday. So if you do that, you should multiply it by that, and you should get 0.15 or 15%.
I don't understand. Why are we using 0.03? Because that's absent and Friday.
Well, if you remember the formula for conditional probability, because we want to find the probability that they're absent given it's Friday. So the formula say you get probability that they're absent and Friday, and you divide that by the probability that there's Friday. So since I know the probability that they're absent and it's Friday is 0.03, you put the 0.03 up there, and the 0.2 you go right there.
Okay.
Okay. Cool. All right. So that's the first one. So let's go ahead and do the second one. So for this one, it says in the United States, 56% of all children get an allowance. 41% of all children get an allowance and do household chore. So what is the probability that a child does household chore given that the child get an allowance? Okay. So for this one, the two events is that they get an allowance and pretty much they do chores. So we're gonna say this is A, this is C. So if you look at the 56%, the 56% is telling me all children get an allowance. So that's telling me the probability they get an allowance is equal to 56%. Any question in regard to probability allowance is 56% or 0.56? Cool. All right. So now if we look at the 41%, it says 41% of all children get an allowance and do chores. So for this one, we'll say probability they get allowance and do chores is 0.41. Any questions so far on the 0.56 or 0.41? All right, so up next, we're gonna find the probability of the given. So it says, what are the probability that a child does household chore given that the child get an allowance? So once again, if you look at it, we have the word given that. So anything that come after that, that's our condition. So the condition in this case will be they get an allowance. So we want to find of this child who get an allowance, how many of them actually do chores? So we're gonna find the probability that somebody does chores given that they get an allowance. Any questions so far for that notation? All right. So up next, we're gonna find the probability of C and A, and we're gonna divide that by the probability of A. So in this case, this and this are the same. So we put 0.41, and you divide that by the probability to get an allowance, which is 0.56. So if you do 0.41 divided by 0.56, you get 0.7321, or you get 73.21%. All right, and that's it for that second example. Any question in regards to the second example? All right, so for this one, I'll just leave it for you for extra practice. And once I upload the notes, I'll upload the answer for this one so that way you can double check to see if you actually did it correct or not.